So I'm going to start straight ahead by telling you that data visualization is a very critical process in any data project that you are taking part in. Through data visualization, we are able to understand things like correlation between different features. We are also able to extract insights on trends in time and things like those. Data visualization can also help us in identifying anomalies in our data, as well as showing any hidden characteristics that may be existing in any provided set of data. So basically, those are the four basic benefits or importance of data visualization. And for this reason, it is very critical that in every project that you take part in, you should dedicate some efforts for data visualization. So when it comes to data visualization in Python, some of the most commonly used libraries include matplotlib, then there is seaborn, and plotly, although pandas is also used for certain kinds of data visualization depending on the need that one has encountered. And so finally, in summing up the issue of visualization, we also have commonly used visualization charts like heat maps, bar graphs, histograms. I think we also have distribution plots, violin plots, and box plots. So those are just a few that I wanted to mention. So in this session today, I'd like to take you through the basic visualization libraries that are in Python and how they can be used for different purposes. So I'm just going to present my screen. So in case you have any problem, just speak up so that I can hear you. I'm not seeing the chat section. Okay, so the libraries that we're going to work with today are matplotlib. Then we'll also explore pandas. Then we need this as well.
They are asking that you zoom the screen.
Okay. So don't know. Is this clear for everyone?
Yeah.
Okay, fine. So we can go on. So these are the plotting libraries that are going to be used today. And I think that image. Sorry. So matplotlib is like basically every plotting library in Python is built on matplotlib, and you can see that from the fact that when you want to perform different functions in your images, in many cases you'll be using the plt function over here, which is basically the entire matplotlib. So I'm going to show you how you can plot several graphs on matplotlib using pandas, using plotly, and using seaborn. So one of the datasets that we're going to work with is the iris dataset. So I'm just going to read it quickly here. So basically, this is a dataset that contains information about the sepal length, sepal width, length, and width of the petals of 3 distinct species of flowers. There is the, let me just print them out. So these are the 3 species, Setosa, Versicolor, and Virginica. So I'm just going to start by showing you how pandas can be used for basic visualization. So once you have a data frame, there is the plot function that comes with this data frame, which can be used to help you in plotting different kind of plots. And so for this case, I'm going to explore one such plot called the horizontal bar graph. So specifically, I want to plot the different counts of each of these species. Like for Setosa, I want to count the number of occurrences of Iris setosa in this data set for this species, and finally for Virginica. So to do that, first I'll identify my value funds. So I'll create a variable, and I'll assign it the value funds over here. Then finally, I'm going to plot I'm going to plot a horizontal bar graph using this value funds as follows. So the kind argument here takes the type of bar graph that I want. For my case, it's a horizontal bar graph. So I'm just going to pass in a title. Let me see. So that's it. We see now that we have 3 species, and each of these species has an equal number of occurrences or frequency in the provided data set. Each has like 50 observations. So that's one way through which pandas can be used to plot a graph, in this case, a horizontal bar graph. We may also want to visualize something like a histogram using a pandas data frame, like using the pandas plot function. So again, I'm going to demonstrate that simply by passing the column that I want to visualize and the kind of graph, which is a histogram for this case. And then it's always a good practice to pass in the title. So I'm just going to say histogram of sepal. So yeah, that's the histogram. So essentially, you can plot different kind of charts using pandas by just changing this argument over here, or by passing the kind argument in the dot plot function. So I don't know if there's any other question after that point.
Okay, excuse me, sir.
Mm-hmm.
Is there a way you can maybe customize the colors? Like we can see the graphs are in blue. Is there a way you can customize those colors? And again,
Yes,
maybe
yes.
increasing the size of a graph.
Yeah,
As
sure. That's very much
library
possible.
provide that.
You can change the size of the graph by declaring something called the fig size. Okay. And I'm going to provide a link much later on in the notebook that I will share with you so that you can see how you can explore the different functionalities of Matplotlib. Because of time, I didn't want to touch on them.
Okay, thank you.
Yeah. Any other question? Okay, fine. If there's none, I'm going to move on to the next library, which is Matplotlib. So yeah. So as I said, Matplotlib is like the most common plotting library that is used in Python. And essentially, like every other functionality or every other plotting functionality in Python is built on Matplotlib. So it's diverse. It can be used for both plotting and reading images as well. So at some point, you may find yourself working with image data, and you may want to print out a few of the images. So I'm going to show you how Matplotlib in general can be used to do that. So we'll start by printing out or plotting an image. So Matplotlib comes with the matplot image functionality that allows us to read an image, and to read it, this is how you call it. And then in here, you're going to pass the name or the path of the image. So for my case, I already have an image called elephant that I'm going to pass there. Then now I'm going to plot it on an axis using Matplotlib. So, and then finally, passing a title over here called now when you call that, you see that this is our image here, and it's been plotted on this Cartesian axis over here. So this may be important when you're trying to define pixels for those of you who may decide to go into image analysis and things like that. Okay, so apart from reading an image, we can also create some basic plots using Matplotlib. So I'm going to show you how to create a basic scatter plot. So you know that a scatter plot has got both the x-axis and y-axis. So for this case, we want to explore the correlation between the sepal length of the flowers and the sepal width using a scatter plot. So I'm going to define my x variable as sepal length, and then my y variable would be my sepal width. So to come up with a scatter plot, simply pass that argument over there, and then you can provide your title as well. Say relationship and finally, I also label my axis by saying the x label here should be the sepal length, and the y label should be the sepal length. So yeah, now this is what we have. We have width in the y-axis and the length in the x-axis. Of course, you can infer from this that the two are not highly correlated. You can just see from the distribution. If they were correlated, we'd expect some sort of a linear relationship between the two. So this is one way of showing you how visualizations can be used to understand the characteristics of our data. So one good thing with Matplotlib is that it comes with functionalities that allow you to customize your graph. So for instance, you may want to compare the sepal length versus sepal width, as well as the petal length and petal width. So basically what I'm trying to say is that you may need to plot more than one graph in the same window. So Matplotlib helps you to do that using the subplot function. So I'm going to say that the subplot function here is used to plot multiple graphs at the same instance. Okay, so I'm just going to convert this to Markdown first. So the subplot function, it takes in the argument of number of rows, takes in number of rows and number of columns, the main arguments. So for instance, if I say x.subplots 2, 1, or let's start with 2. So since the argument has the number of rows and number of columns, it will by default provide a graph with, or rather an output with 2 graphs in 1 column. So yeah, this is 2 graphs in 1 column. So if I say x.subplots 1, 2, then it's going to be, it's going to be 2 graphs in 2 columns, 1 row. So of course, x.subplots 2, 2, and make a guess for yourselves. So I'm just going to show you how you can create a simple action subplots using the 1, 2 argument, and then I'll expect you in your own free time to explore other functionalities as well that are presented using this subplot function. Okay, so for this case, I'm going to compare the sepal length and sepal width, as well as the petal length and petal width using the subplots function. So I'm going to create my 2 figures, and then the axis as well. And the argument will be plotted.subplots 1, 2. So it's 1 row, 2 columns. So in my first graph, it is labeled axis 0 because indexing in Python starts from 0. We're going to pass in the scatter plot that we had defined earlier. And then in my second graph here, I'm going to pass in another scatter plot, but this time using the petal length and petal length and petal width. Sorry for that. in arguments. Okay. So now if I call it, you've seen I have two graphs here. I have not passed in the axis labels, but we know from the previous example that this is for the sepal length and sepal width. Then this is for the petal length and petal width. So already, if you are keen, you can point out a clear distinction between these two. You can see that the sepal length and sepal width are less correlated as compared to the petal length and the petal width. So if you are kind of making some studies on this flower species over here, you would already have come up with one major observation that could be critical in your analysis or your subsequent studies. So up to that point, do you have any other question? Okay, I'm assuming there's none. So I'm also going to briefly touch on seaborn. So there's no major difference between seaborn and matplotlib because basically they both kind of work in the same way. However, seaborn tends to be like customizing a graph on seaborn is much easier than doing the same on matplotlib, but the output is more or less the same. So since there's no much difference, I'm just going to show you one kind of unique graph that can be plotted in seaborn called the distribution plot. I think we had already touched on it much earlier on. And so just to show you again my getfn. So these are my columns, and now I want to find the distribution of sepal length, for instance. I can say that sns.dist plot. Then my column of interest is that. So I'm passing a title again. So now you have a distribution plot for our sepal length, and you can see that it was almost becoming a normal distribution. Yeah, so basically that's all about seaborn. There is nothing much unique or different. So in your further reading, I hope you're going to check more on matplotlib and seaborn as well. So yeah, that's all about it. I'm going to touch on next on plotlib because it's kind of unique. So far, these libraries that you've mentioned here, pandas, matplotlib, and seaborn, they come in very handy when you just want to like visualize your data once and be done with it. But often, or when you start coming up with solutions for real-world problems, you may find yourself needing to display this data in an updated manner. For instance, you may be interacting with live data, and now you want your visualizations to update themselves in the same frequency as the data is coming in. So that's where Plotly comes in. Plotly is a plotting library that is commonly used when you are deploying our applications. So if you've created a web app, for instance, for visualization purposes, using Plotly, you'll be able to connect your app to your database such that the visualization is updated as new data is obtained from the database. So apart from that, Plotly is relatively easy to use, and I'm going to show you how you can create some different kind of plots using Plotly. So I think I'm going to start with a simple one. Let me see. Can someone suggest what kind of chart you'd like me to plot given this kind of data over here? Can't think of any right now. Hello? Any suggestions? Okay, fine. If there's none, then I'm just going to select a random one here. I'm going to plot my petal width against petal length again. So this, then my x-axis over here is then okay, so we have this not so pleasing thing here. It's because I can't think of an appropriate graph to plot using Plotly based on this data. However, to demonstrate the functionalities of Plotly, I'm going to use a more robust data frame called the Gapminder data frame. So Plotly, by default, it comes with this data frame installed. I think this is how you call it. You just pass in the .data argument, then you pass in the name of your data. So it's Minder. So let me just explain something about this data. So the Gapminder dataset is a dataset that contains demographic characteristics of countries since 1952. So it has data for like every country in every continent since 1952 to 2007. Some of the variables that are of interest are the life expectancy over here, the population, and then the GDP per capita. So I'm going to use this data frame here to explore some of the functionalities of Plotly, and specifically my interest will be on African countries. So I'm going to filter them out. The continent. The continent of interest is Africa. So now have all data but for African countries alone. So we can plot a basic line plot using Plotly, the one that I wanted to show you in the previous section there. And in this case, I want to plot like the life expectancy of a specific country since 1952 up to, I think, 2007. And I think it will only be logical if we use Kenyan data. So so now if you look at the number of years in the Kenyan data, you see that we have data from 1952 over here to 2007 in intervals of 5 years, that is. So if you want to evaluate the life expectancy trend in Kenya since 1952 using Plotly, you can simply come up with a line plot by passing in this argument. So the first argument is providing the data frame name that you're interested in. For our case, it's Kenya, so we are going to pass in Kenyan data. And then we're going to pass in the x-axis. So in our case, the x-axis will be the year. So we want to evaluate the life expectancy change every year. And then in our y-axis over here, we are interested in the life expectancy. And then finally, we can pass in the title of our graph here by saying life expectancy trend. And since so now this is what we have. We have our year on the x-axis, and then the y-axis we have the life expectancy. Then we have the trend over here. So one good thing with Plotly is that it gives you like an interactive graph. You simply hover around and it will show you the specific value. Unlike Matplotlib and Seaborn, where you have to approximate, you can see in Plotly it will show you the exact value, so you don't need to approximate. So I think that's one of the reasons why it's preferred when it comes to cases of deployment. So yeah, again, another thing about Plotly is that you can download your graph by simply clicking here on download plot as PNG. Then once it's downloaded in your local machine, you can save it and then maybe attach it to your document or something like that. So you can also zoom in and zoom out of your graph. I select zoom in, for instance. What's happening here? Okay, there's zooming in here and there's zooming out. And then you can reset the axis. Yeah. All these are the functionalities in Plotly. So that's a basic line plot. You can also come up with a pie chart as well. So depending on how you have structured your data or what kind of analysis you want to come up with, you can come up with different kind of plots. So the last kind of plot that I would like to show you using Plotly is the choropleth map. So for those of you who may have done some bit of geography, I think back in high school you were taught about choropleth maps. So these are things that maps that can be used to like represent characteristics of different regions. For instance, if you have the population of a country or of a continent, you can use a choropleth map to show the individual populations of individual countries. So I think Plotly also provides us with a similar kind of function here. And for this case, I'm going to bring this up here. Yes, in this case, so in this case, I'm going to compare the life expectancies of different African countries, specifically in the year 1952. So using a choropleth map, so I'm going to call my new data frame as life expectancy in 52. So if we check it out, see that you only have 1 year in our data frame. Now, to plot a choropleth map is the same procedure as a line plot, but this time we change like the kind of plot that you are interested in, as well as some little parameters in there. So before I continue, when plotting a choropleth map, you need to have a column that can be used to identify the countries like uniquely. So in my case, I have the ISO alpha column over here that contains the encoded name of different countries. And the encoding is in such a manner that it coincides with what is expected in a choropleth map. Like I think, for instance, if you look at Algeria, it's not encoded as Algeria. It's been given the code name BZA. And so if you're more interested in this, you should check out Natural Earth, because the map that you're going to use is extracted from Natural Earth. Okay, so having said that, I'm going to create a map for Africa here, and I'm going to call it the African expectancy in 1952. It's going to be a choropleth map. Then the data that is used is the life expectancy in 52. And then the locations column here. So these are the columns that will be used to identify the countries in the map. So the color of interest will be obtained from the life expectancy. So we want different life expectancies to have different colors. Then sorry, the hover name over here should be the country. So essentially, I want, when I hover my mouse over the map, it shows me the country of the specific, or it will show me the name of the specific country that the mouse is over. Then finally, I'm going to pass in some color arguments as well. Yeah, like color continuous scheme. This color is not scale. And finally, the projection, the natural arc. Okay. So now if I call that, it's going to give me a projection of the expectancy rates of different countries in Africa in 1952. So if I zoom in clearly, you can see that the two countries with the highest life expectancy years of 52 were Botswana over here and Zimbabwe. And I think the countries with the lowest, yes, this is the lowest expectancy rate. We have Angola over there, then we have Burkina Faso, Sierra Leone, and Mozambique. So our country, Kenya, here has an expectancy rate of, had an expectancy rate of 42.27 in 1952. And we can see that this map is up to date because as of 1952, South Sudan here was not independent as a country, and therefore there's no data about it. Yeah, so basically, Plotly also has some other unique functionalities, but I thought maybe I should start with these ones to appease your appetite so that you can go and check them out. Like I said previously, these sessions are just meant to give you a general overview of the details of different steps in